Hi guys, welcome to Origis Computer Classes once again. How are you all? Hope you all are doing well. Okay, so I hope you have watched my lecture on structures part 1. Okay, where I have discussed basics of structure. Okay, and what structure is, why do we use it. Okay, right. And so here I have brought up structure part 2 of structures. Right. uh, what are structures basically? Okay, a short recap. So they were like user defined data types. Okay, like the primitive data types are there: int, float. Okay, so structures are user defined data types where we can create our own data type with some modifications. Okay, like say in the same memory space we want to have uh, other details, right? In that case we can use structure. Together we can just merge a group of data types, primitive data types, and give them a structure to form our own data type. Okay, now today in this lecture we are going to see how can we create array of structures. Okay, now why do we need an array of structures? See, say suppose I've given an example. In a class, okay, we will be having around 60 students, okay, in a particular course. So how, and if we use primitive data types to store their details, see, we can use array. Okay, but see how many arrays we need to use for storing their name, for using primitive data types. So as an array of strings can store only string values, right? So for just storing their name, we need a character array, a string array, right? And again, for separately storing their roll number, we will be needing a separate array, right? That means to store separate details, we are requiring separate arrays, okay, and of the same size, right? If we are having 60, so each array of 60 is of size 60, okay, and it will become hectic to access them and obviously to store them also. Using structures, what can we do? Say I am defining, we can just define our own data type, right? Say I'm defining a data type called struct student, right? Struct student, and opening this, then character name, say around 20 size, then their roll number, int roll number, then we are going to have their course name, course, okay, because course name will require some space, okay, and that's all. Or you can say, if the results are coming out, you can just also store their grand total, right? Int grand total, and this is how. So closing of structures and semicolon, okay. So now no memory has been allocated, but we have just created our data type. So if we define any variable of these data type, this will be having these blocks, right? Just if you can recall my lecture 1, my previous video, there I have shown, if I declare a variable of struct, say struct student s1, so what are the fields this s1 is going to have? S1, and it will surely have some memory address, say 1000, right? So here we will be having S1, okay, and say name, okay, name, then roll number, fine, then course, and grand total. Right. Now see, this is just a pictorial representation of the template, but how actually in memory does it get stored? S1, if I am storing details of student S1 in memory, see memory is a long strip of block, right? So in memory it will also again be stored like an array. These 4 blocks are also again stored like an array. Say if I am having the address of S1 is 1000, then base of this is actually 1000, okay, and it is having at index 0 the name of the student, field of name, then it is having roll number, okay, it is having course, and also the grand total variable. Actually this is creating an array, but an array that can store data of different data type. Till now when we are having primitive data types, we are using such arrays which can store only elements of same data type. See, say means in integer array you cannot store float value, right? But this is an array actually which is able to store elements values of different data types. Yes or no? Right? So in this way, fine. Now that means, so it will continue, right? It will continue like this. And what is the total space this data type is going to have? Character 1 byte, okay. I am using 64-bit compiler, say int 4 byte, character again 1 byte, and int again 4 bytes. So 4 plus 4 8 plus 1 9 and plus 1 10 bytes is total going to occupy. So of course you can understand this 10 bytes will be stored in the memory like this, okay. 1000, then after one space in 1001, okay, in 1001, okay, then after that, because see, no, I am extremely sorry, not in 1001, because character name is taking 20, right? 20 blocks it will take to store the name, and after that at 1020 1020 we can have this roll number, okay, and so on, as you can say. But when we are creating, see, now for a single student this is how it will be stored, right? But in the class we are having say around 60 students, okay, around 60 students. Hope you please take a screenshot of this, right? Taken, okay. So in a class we are having say around 60 students, and for all those 60 students we need to have these details: name, roll number, their roll number, then course name, and their grand total, right? So instead of taking a variable of type struct student, we can easily take an array of type struct student, okay, right? So say I'm taking students of CSE, Department of CSE, okay, Computer Science and Engineering, okay, or better say I'm taking a broad range, say I'm taking BTech, okay, under BTech there are many other courses, fine, and in BTech course we are storing the name of the toppers from each department, okay. So say around there are from CSE there is one topper. From CSE cyber security there is another topper. From electrical there is. So I am taking 5 names. Okay. So an array of BTech. Okay. So of CSE of BTech. Okay. I am writing here in short BTech, and 5 students. They are the toppers from their departments. Okay. And so of course we need to store their details. Now how will it look like? The BTech array will be something like this. This will be my BTech array. It will be having size 5. Okay. Wait. Let me draw it here. BTech array 5, size will be 5, and these are the blocks 1 2 3 4 5. And say it is having a base address 100. Yes or no? It is having a base address 100. Now with my using my previous concepts, can you tell me what will be the address of the next block? Just pause the video and think for a while. Okay, done. See, this is 100. This address is 100, and each data of struct student data type is taking 10 bytes. Yes or no? 10 bytes. So after 100, the next will be at 110. Yes or no? Next will be at 110 and 120, so on, 130, 140. 0, 1, 2, 3, 4. And index 0 represents one student, index 1 represents second student, index 2 represents third student, and so on, of course. That means each individual block is going to have the same structure as I have drawn for for a single variable S1. Just I have shown you. So if I am talking about block that is having address 100, index 0, that means I can say BTech of 0. I can write BTech of 0, right? BTech of 0. So it will be having name, right? Name. It will be having roll number also, roll number. Then course, right? Grand total. Right? Now just tell me, is it something like which system is going to store? No, right? See, for a single variable, just as I've shown you, it will also be stored in the form of an array, right? A strip of memory will be given for these blocks. Yes or no? Yes. So similarly, for BTech of 0 will also be stored, like BTech of 0, if I draw here, BTech of 0 will be having blocks of, say, at the address 1000, it is storing name of the student. Okay, is storing name of the student. At index 1, it is storing roll number, right? Similarly, course and grand total. Okay. Right? So that means we can of course we can store using this BTech of 0. So btake of 0 will be consisting of the base address of this array, right, of the base address of this array. Okay, say 1000. This 1000, it will be pointing at the base address of this, right? Similarly btake of 1 will be starting from a separate address. Say btake of 1, the same 5 blocks, first for name, second for roll number, then for course, and for grand total, right? This is how it is going to store actually. Does so btake of 1 is having this. Got my point? So now it is having, say, a base address of 2000. So 2000 will be here. It will be pointing to the base address of this one, right? This is how all the blocks will be stored, the structure. Got my point? In the memory, if even this template is stored like this. See, when we are declaring this template without declaring any variable, so this is like a template. Okay, I am just defining the data type, what it is going to store. As soon as we are creating an array or a variable of that data type, of course I am allocating memory, and memory, of course, you know what is this. Memory doesn't know how to store this. Of course, memory is a long strip band, right? It will be storing something like this in the form of array, definitely. Fine. Now the point is how we are going to fill up these details. Okay, understood this? This was a bit about how system is working on structures and also the array of structures. Okay, so I'm erasing this, right? So for storing in array, we need a for loop, and mostly in these cases the details are given by the users only, right? Now btake of, if I am storing it manually, then say btake of 0 is equal to, see, btake of 0 is a student, detail of the first student who stood first from his department. So see, btake of 0, as I discussed in a previous day, btake of 0 is equal to, say, d. Okay, then 11, then I can say course is CSE, and grand total, say, 900. This is one way of storing the values. The second way is, if I want, I can also write it like this: btake of 0 dot name is equal to AD. Yes or no? btake of 0 dot roll number is equal to 11, right? And so on, right? This is how we can store the values, right? So similarly for btake of 1, okay, at index 1 there will be another student. Now it is not possible that every time, each year, we store them manually in the program. We need to reopen the program because we are developing softwares, right? and user is certainly going to store that values. Okay, store those values. So for that, what we can do is we can use a loop, for loop, for just like we have used for the arrays. So this is also an array, and we are going to use the for loop. So say for int I is equal to 0, I less than 60. For now I'm defining 60. In real life, this size will also be given by the user, that you know very well how to take, how to take input from the user of basic normal variables. Okay, so btake of I write btake of I dot name. Oh, I am going to take input from user, sorry. So I am defining a variable again here separately, char name, or wait, get s. I am using get s. You can also use fget s, but I am just showing an example, right? So practically when you are doing the program, please use fget s. Okay. Now, so I can write btake of I dot name, right? Or what you can do, see, it is not possible to take in this way because using gateS you cannot store so much inside, and gateS is insecure to use. What I can do, I can take a separate variable, say char name 7. Now from user you just take the value of this name, capital name, gateS name. Okay, so every time the loop will run, it will just ask for the name. Okay, and you can just add a message here before enter name of student 1. I am just showing you the pseudocode example, and you can just copy it strcpy using the library function strcpy btake of 0 dot name comma name. Okay, this you can do, right? Fine. btake of 0 dot name comma name. Okay, next what you can do is similarly you can just other variables you can take the input. So scanf, not btake of 0, it's btake of I, scanf mod d comma btake of I dot roll number. Yes or no? btake of, in this way actually we are accessing the values, the blocks of each index of this btake array, right? Of this btake array. Okay, so okay, this is how you can store the values, and similarly you can also take input for this course also. Again you can take another variable and copy it. Okay, scanf again mod d ampersand btake of I dot grand total. Right? Thus this is the way of storing, taking the details. So how easy it has become. See, if we are using array, using of primitive data types, for each individual details, for storing each individual details, we are requiring separate arrays, right? But see, defining your own data type makes it easy, right? Without using any primitive of course we are using primitive data type inside, but see, this becomes easy. I mean, for one single element you don't need to create any separate data structure for each details, right? For name we are taking one array, for roll number we are taking another array. Okay, not required. This is how we can do it easily. Okay, so I am doing it for btech of I, for a variable, for index. And so as soon as, for if I turns out 1, so it will be storing name of index 1. Okay, student at index 1. I turns 2, it will be storing name of student at index 2. Okay, this is how we will be getting who has turned out first, second, third, and so on. Okay, in the whole department. And as you know, return 0 and closing of main. After this, okay, here there is no space, you can write here return 0, closing of main. Okay, this structure of C program, right? This you can do it. And of course the header files you must include. So this was about all about structures. So basically these are like the examples. I have used a few examples where I can use structures, okay, to make it easy, for make it efficient for storing data. Okay, but in reality there is a concept called linked list. Their structures are used more because these values are basically stored using linked list, because we do not know. See, this is for students, we know the number of students are specific, but there are cases where we do not know how many persons are going to be there. Okay, like for banks and hospitals, as I gave example. So linked list is a better option, okay, than array, right? But this is a dummy example how structures can be convenient for you. In the next video, in my upcoming video, I will be discussing a few questions related to structures, okay, that may come in your exams, in your semester exams. Okay, so that was all about today's class. Thank you, bye bye, take care.